Okay, now that we've gone through and looked at some of the major differences between linears, quadratics, and exponentials, let's review them. So which type of function has a constant rate of change? That would be a linear. Which type of function is the second difference, but not the first, is constant? So the change of the change is constant. That's a quadratic. Which functions have graphs with no vertex? Well, the only one that has a vertex is quadratic, so no vertex would be linear and exponential. Which type of function could have a graph with no x-intercept? So which type of function could possibly not touch or cross the x-axis? That would be a linear, a quadratic, and an exponential. Which type of graph could have two x-intercepts? That would be a quadratic. Which type of graph has one y-intercept? That's all three of them. Which type of function has a domain of all real numbers? Again, that's all three. Which one has a range y such that, so this vertical line is such that y is greater than 0? So in other words, which one has a range where you can get anything larger than 0 for y? That would only be exponentials. Which one has a range y such that y is less than or equal to 0? So you can get 0 and lower for your y values. That would be a quadratic. Which one or ones, which functions have a range that is all real numbers? That would just be linears. Okay, let's see what we learned about our tables. Take a minute and go figure out which table is linear, which table is quadratic, and which table is exponential. Now that you've tried them all, let's review. In the first table, your x's are all going up by 1, and your y up by 1, up by 3, up by 5, up by 7. So this one cannot be linear because your change in x, or your change in y divided by your change in x is not constant. So let's go look at the second change. From 1 to 3, add 2. From 3 to 5, add 2. From 5 to 7, add 2. So the change of the change is constant. So this one is quadratic. Let's look at the next table. Looks like we're adding 3 to x, add 3, add 3, add 6. Okay, so the change in y is not, or change in x is not necessarily constant on this one. Let's see what happens with y. Add 6, add 6, add 6. So right now it's looking like it should be linear because every time I add 3 to x, I'm adding 6 to y. And then we get to this jump down here where they add 6. So this jump is twice as large. So 37 minus 25 is 12. So is the change in y divided by the change in x constant for this one? So you have 6 over 3, which is 2. And you have 12 over 6, which also works out to be 2. So the change in y divided by the change in x is constant, so this one's linear. Well, using teacher logic, the last one has to be exponential. But let's take a look at it. It looks like all of our x's are going up by 1, and our y's, 2 to 6 is 4, 6 to 18 is 12, 18 to 54, so 54 minus 18 is 36, and 54 to 162, so 162 minus 54 is 108. So the first change of y is not constant. So let's look at the second change. From 4 to 12, you would add 8. From 12 to 36, so 36 minus 12, you would add 24. Okay, the second change isn't constant. So let's see if we can find something they're multiplying by. So 54 times what would give me 162? So 162 divided by 54. Punch it in my calculator, I get 3. So from 54 to 62, they multiplied by 3. What's 54 divided by 18 then? Punch it in my calculator, also 3. So 18 times 3 is 54. 6 times 3 is 18. 2 times 3 is 6. So they're multiplying by 3. So this is exponential. So as we consider some real-world situations here, keep in mind linear means you are adding the same amount every time or subtracting. Quadratic would be like an object that is falling or something that's shot out of a cannon. So you are not adding the same number every time. Exponential would mean you are multiplying by the same number every time. So growing a culture of bacteria, probably not just like adding 2 every time. It's not an object that's falling or being launched. So it's exponential. It's going to double or triple or cut itself in half. The distance a Boeing 737 MAX can travel at a certain speed over a given period of time. So it sounds like the plane is going a certain speed. So it's keeping the same speed. So that means you'd be adding the same amount every time. So that's linear. Kicking a ball in the air, so it's got to go up and come back down. That's quadratic. Running a race at a constant speed, well, we're going a constant, so that has to be linear. A pumpkin decaying, it's not going to be taking away the same amount of pumpkin each time. It's not an object that's flying, so it's going to have to be exponential. Jumping from a high dive, so you're not going to be moving at the same speed. Anything that's flying or jumping or throwing or launched, that's always going to be quadratic. Complete the following table so f of x represents a linear function and g of x represents an exponential function. So f of x, we need to add the same number every time. So I'm going to make up an example. You are going to have to make up your own example. So the example I use is not the one that you can have. So for mine, f of x, I'm going to add the same number each time. So let's say we start at 10, and I'm going to use the pattern of add 2. So you're not allowed to start at 10, and you're not allowed to use add 2. So in linear, every time x goes up by 1, I should be able to add 2. X goes up by 1, add 2. X goes up by 1, add 2. X goes up by 1, add 2. So that would be a linear pattern. G of x has to be exponential, meaning I need to multiply by the same number. So again, I'll make up a pattern. You're not allowed to start at the same place. You're not allowed to use the same multiplier. So I'll just start at 10 again. And this time I'm going to multiply by 2. So you can't start at 10, you can't multiply by 2. So x goes up by 1, multiply by 2, 20. X goes up by 1, multiply by 2, 40. X goes up by 1, multiply by 2, 80. X goes up by 1, multiply by 2, 160. So now you make up your own pattern and show it to your teacher and get it approved.